And so in the previous video, we stopped at this picture. There are two technical solutions. There may be 3, 4, 5, but only two technical solutions have come to mind. Let's move on to the next slide. So here's the number one technical solution. The first picture we see here. What we see here are two control centers, yellow squares I've circled. It means an inductor that controls the voltage on the capacitor plates. That is the voltage in the cell itself. There is also a control center that regulates the frequency for resonance and regulates the supply voltage. It looks something like this, a pulse generator, which has two regulators. The voltage regulator and frequency regulator and the inductor on which the voltage on the Meyer cell covers is controlled, and graphs are drawn. This graph shows the power voltage of the pulse generator, which shows the frequency. And the third graph shows the voltage on the Meyer cell electrodes. As you can see in this picture, you can see that the green square is surrounded by the regulator that we're going to regulate. Those who are not bound are like constants. That is, we are now at a stage where we turned on our installation and the voltage on the pulse generator set 30 volts. The graph shows 30 volts. We set the frequency to 0, and the voltage on the inductor was set to a minimum. And when we turn it on, we get the voltage on the electrodes of the Meyer cell that's not quite as high as brown gas. Let's say it's 500 volts. I immediately warn you that all figures are conditional. They are designed to understand the logic of the work. When we turned on, set the voltage to 30 volts, and the rest of the regulators made the constant to a minimum, we moved to the next stage. Now we have to do the following. We have to pick up the voltage on the inductor at which we emit brown gas. And again, experimentally, by adjusting the inductor, we found that we have a breaking voltage of 1000 volts. The number is conditional, I repeat. We put the voltage on the power first, then put the voltage on the covers of the capacitor of the Meyer cell. Now we need to pick up the frequency. So we move on to frequency selection. Through manipulation and frequency selection, we found that we have a voltage resonance at a frequency of 15 kilohertz. Again, the numbers are conditional. And as a result of that resonance, we've got 1000 volts going up to 2000 volts. That is, we have a reactor, that is, a Meyer cell, went into the boiler mode, that is, the voltage is too excessive and it comes out in the form of heating water. And then what we do is we have to reduce the voltage to 1000 volts. We do not touch the inductor because it is in an oscillating circuit and is part of the resonance. We have to reduce the voltage of the pulse generator. So 30 volts you drop up to 12 volts. And we reduce the voltage in the Meyer cell on the electrodes to 1000 volts, which is the voltage at which the molecules break. And then you start a dynamic image. You can see it in what order bits happening. Well, that's it. This is the number one technical solution. It's not perfect. It's a technical solution designed to gain a statistical base. In order to subsequently abandon the variable inductor. Why you have to give up later will be in the next video. That's all for today. All the best. Subscribe, like. You can put in the comments on if you like. That's it. Goodbye.